back to this restream chat. That works too. Let's see here. Let's bring up YouTube. Public. Yes, okay. All right. So, let's see. like that. This is just gonna have to be washed out. Do I have my popcorn? Yeah. So, I thought I would try streaming the rebuild of my 2E tonight, just for kicks, because I need practice streaming for another project. I'm no good at it, but what the heck. So anyway, before I get into that, this is the 63.5 watt 110 volt power supply out of an IBM PCXT. I flipped it on when I got the machine and I heard a pop, and that was all there was to say about that. So I set her aside and didn't take another look at it until sometime later. And I opened it up a couple days ago and I started looking at it. And as I went through it, I started looking for what went pop, and I don't see it. Just at a high level inspection. Of course, I haven't taken anything apart yet. But this is the AC input board where the power comes in and gets filtered before it gets stepped down and transformed to DC voltage down here. And these are the line filter caps, and they usually are what go bad. Usually they're cracked and bulging and the first thing to replace. A lot of people don't even bother replacing them because they're not really that necessary. But in this case, I don't know that that's what the issue is. And I don't really know much about power supplies. They're kind of enigmatic and therefore scary to me. And this is something you can actually get AT power supplies, aftermarket power supplies still today. In fact, I found one. Let's see, I think it's 3. Yeah, there you go. I found one on Newegg, 300 watt AT power supply. And the reason why it has to be a specific AT power supply is because the power connectors, the connectors that mount to the motherboard, which are these things, supply a series of voltages. And if you get an ATX power supply, which is a standard power supply for most computers today, not only are your plugs going to be different, which is fine. You can rebuild the harness to fit an AT motherboard, but the voltages on that aren't the same. And that is that there's a plus 12 voltage, a minus 12 voltage, and a plus 5 voltage, I think. But the old AT power supplies required plus 12, minus 12, plus 5, and minus 5. And so it's that missing minus 5 that's the real problem. So if you can find an old AT power supply, or you can find something like this on Newegg, then you should be in business. And for $40, honestly, it's probably worth it just to buy that and try to make that work. I haven't really done my research yet, so I don't know what the best solution is, but I'm kind of inclined to fix the IBM because the IBM power supplies were really well built. I probably shouldn't be touching this given that it's plugged in. Anyway, they were really well built. In other words, they had overvoltage protection built in. So if something went wrong and the voltage went too high, which is really, really bad for components, it would shut down automatically. And that's not common with power supplies of that era. Power supply technology in the early to mid 80s wasn't all that great. Probably wasn't even through the mid 90s. If you've got a Commodore power supply, this is an old Commodore power brick right here. Most of these things still work, but when they fail by overvolting. So if your power supply goes bad while you got your C64 plugged in, chances are it's going to burn out your entire computer. So Commodore 64s, you either have to build a special circuit in that will protect the computer from overvolting, or find a different power supply entirely. Not so with the IBM. The IBM power supply design actually was way ahead of the curve as far as power supplies of that day. So, to me, just because of the quality of the supply, I'm really inclined to rebuild it if I can. But I really don't know if I can. So anyway, just to show how far or how much I've figured out, how brilliant I am with this stuff. I got my multimeter here, whatever. See if we can zoom in a bit. Hey, look. I hand it. Little iPhone 5S doesn't make such a bad camera. So, try that. There we go. So, this board here is where the AC comes in. And, I wonder if I could prop that up with anything. I don't really have anything here I can use. No. If I take, so a good spot to check voltages. This whole board here is going to have AC current running through it. And a good spot to check voltages will be right here on the line filter capacitor. And if I just touch the leads, flip the power supply on. There we go, we're on. If I just touch the leads, there we go, I'm reading 123 volts, thereabouts. So I know my line filter capacitor is taking AC current, and this whole board basically filters the AC that comes in to make sure it's a more constant voltage. It's fused, so if anything goes wrong, it'll blow at that point. And it has some other regulation stuff. Like I say, I'm not a power supply guy at all. But the whole thing comes down to this harness here onto this main board, which then transforms it down to DC. It actually transforms it to DC while also supplying AC for peripherals. In this case, it would be the floppy drives. And these are the same style of connectors as you're going to find for, a CD-ROM or a lot of your more recent technology. These connectors didn't change for a number of years. So anyway, here at the harness, I put my black on neutral, I put my red on black, and there you see I got another 123 volts. So I'm seeing power all the way to the harness, and that's good. And if I shut it down, oops, fell off the black there. And if I shut it down, it bleeds out pretty quick. Oh, there we go. There's some residual voltage right there. So now you see that there's still this residual voltage in the system. That's because those capacitors are slowly emptying. And they'll drop down to a volt pretty quick. Or a couple volts anyway. But so far as I can tell, for what little I know about power supplies, we're good at least till we get to the main board. But something is happening once it gets here. And on these connectors, I'm registering maybe 8 volts AC. And on these, where I can register voltage, I get 3 1/4. Now, these aren't designed to really function properly unless they're loaded. And I could hook it up to the original components, the original motherboard, but given that I don't know how well this works, I'm a little disinclined, shall we say, to do that. So, I'm not exactly sure what do next as far as rehabbing this, and I may not. I may just end up replacing it and calling it a day. In any case, get this out of the way. Kill that for a while. The other thing that I encountered when I pulled my IBM motherboard, let's see here. You can see that. Here, let's go back to Full screen. There we go. Well, that's better. What if we zoom out? Wrong way. There we go. Come on. There. So the other day when I pulled my motherboard and pulled all the chips out, might be kind of hard to see, but there's a lot of corrosion in the sockets and here in the two slots that didn't have cards in them. I mean, the board's absolutely filthy. I still got to run it through the dishwasher. But there's plenty of corrosion, so it took an awful lot of water damage from the top down. Bottom side looks really, really nice. Nice and clean. I see maybe a couple, I see maybe a few solder joints on the back that are corroded, but just a few. So at least the damage is limited to the top, which is, I guess, what you would expect. So I have a bunch of sockets here to replace. I actually tested continuity across the memory sockets here in the 3 memory banks, and it actually tested okay. But I still think I'm going to replace some of those sockets because some of them look pretty nasty. That said, it'll be a long road getting that working, because when I pulled the ICs, see if I can find a good example here. Here we go. Maybe that's not a great example. When I pulled the ICs, there's a lot of them have suffered corrosion. I'll bring that up as close as I can here. I don't know how. Yeah, there you can kind of see, maybe if the camera will focus on it. Yeah, kind of. It's not going to work so well. But anyway, the legs on the ICs, a lot of them have this rust and corrosion. And since electrons travel on the surface of metal and not inside it, that's kind of a problem. And even if I could burnish a lot of that corrosion off, if water has gotten into the IC itself, it's pretty much a lost cause. And those old 64K memory chips, those are replaceable. But what really worries me is the condition of the CPU chip. And you can kind of see there, I don't know how well you can really see it in the camera, but you can kind of see here on the end pin especially, there's rust and corrosion, and I can see it in the light as I look at it. So I really have no idea if the old 8088 CPU is going to work for me. They're not too hard to find either, I suppose, but all the same, I'd like to have it working. And the other thing that further complicates it is I don't have a known good to test against, so this is all I've got. I think the board itself is actually in pretty good shape. I think with new sockets, I don't think there's really anything wrong with the board itself. But God only knows how many of those ICs are bad. So I don't even know if this is salvageable or how much money I'd have to sink into it to make it work again. But yeah, we'll keep playing with it. So anyway, what I really thought I'd focus on tonight is my Apple power supply. So my Apple power supply, do I still have my cord plugged in? It's not up here, so where did that go? Here it is. So I plugged in the Apple power supply and I just ran it just to see what it would happen. Unplugged it, of course, from the computer. And if you could hear it, you hear this click, 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 click going on, kind of like a dirty bearing or something like that. And I think it's called the click of death. Some say it can be really difficult to troubleshoot. Others say, nah, it's just a few caps that you got to replace. I really don't know. Again, power supplies are kind of an iffy thing to me, and while I might like to save the IBM, the Apple power supply, was not built nearly as well as the IBM one was. So erring on the side of caution seems reasonable to me, and I was thinking I might just use this replacement power supply, which I picked up from, there we go, Reactive Micro, and by the looks of it, they hand build these made to order or something like that. I'm not exactly sure. Maybe they have these at least somewhat pre-built, but looking at it, it looks to me like a good bit of this was handmade. Anyway, they sell these rebuilt power supplies, or these brand new power supplies that work for, I think, pretty much any vintage Apple computer. So I thought tonight I'd pull what's left in here out and replace it. So I guess I'll get started if I can find my screw gun. Here it is. Now I need to also find this, and there's a PH1. There it is. It's too big. It's a 0. Yep. So set that aside. Take our screws out and see what we've got inside. Oops. Don't really have a proper size 0 bit for this drill, and it proved exceedingly difficult to turn by hand, so I have to make this work. There we go. Switch back. Oops. Hey, look at that. No idea what that does, so I suspect I have to pull it out. And, ooh, there's something loose in there. Okay, what else? What's this? Something. So that's wrapped around. Oh, so rivet. So I'm guessing the whole thing. Aha! Brilliant. Oh, I see. Split washer. Ooh, it smells good in there. Ooh. There, this way. It's kind of pretty. Looks really clean, given where it's spent probably 20 years or so. I have to admit, I kind of hate to take it out, but at the same time, I really think it's probably for the best. So, brother, I don't see anything in there that shows like it's ready to go. Nothing broken, nothing obviously leaking. That doesn't mean much, but doesn't look terrible anyway. So what else do we have? Okay, so okay. Didn't realize I kind of sat down in a pan like this. Thought it would have been reversed. And then this. This would be why. That's okay. Let it drop. There we go. Oh. Just wondered why that wasn't hooked up to anything. It's probably because I unhooked it. Okay. So. Grommet. Not exactly sure how that's supposed to come out. Is that squeeze in? This obviously flexes. Let's see here. Maybe I don't need to worry about it. Let's see. Does this come out? Yeah. It's coming loose anyway. I'm probably a bit of a dummy as far as how this goes, because honestly, I've never torn one of these apart before. Seems kind of obvious, but I don't know if we can't get under there. Pull that loose. This doesn't want to seem to come off the back. It looks like it might be soldered, or crimped at least. Crimped, yeah. Well, what cables do we have? We've got a brown. And we got this blue one. The brown has an L next to it, so I'm guessing that's my line. Right. L and line and neutral. So brown is line and blue is neutral. Because, you know, those are totally common colors for hot and cold. So this whole thing is essentially loose. I don't think there's anything apart from these pieces that are keeping it from coming out. I don't think I want to do that anyway. I think I want to leave that where it is. The problem is I can't get under it. Yeah, I never said it would be easy. I don't want to cut that too close. I want to cut that at the board. And if I could get this out, I might be able to pass it through that hole. Maybe. There's no way my fingers are going to get under there. Get that bottom side. All I can do is tip this top part out. I don't think I can move that far enough to make a difference. Even if I release this, I still won't be able to get it up because of this. Boy, that's tricky. Can I get this? I am really not sure how to get at that, because I just don't want to. Well, hang on. This is going to be positioned in here like this. So my AC connection is way back. And they did give me blue and brown wire to oh, I don't want to do that. They gave me a couple scraps of blue and brown wire to extend it if I have to cut them short. I really don't want to do that. Oh, I really don't want to do that. Maybe I just have to work this off somehow. And it's crimped on. I just don't think I'm going to get that. I'm afraid I might damage things if I do. You can see the back of that wiggling. Yeah, I just don't want to do that. Phooey. So this I can press down. I can almost push out. But even that I can't quite push out. Honestly, I don't see how that's going to come off unless I pull that loose, and I just don't think that's going to slide off without damaging the switch. Yeah, I don't know, maybe not. Let me get the bottom one to move a little bit. Hey, look at that, it did come. Okay, now let's try this. Okay, well, I got the bottom one off. Let's see if we can get the top one. Yay! Hey, look at that. Okay, well, there's progress. Maybe. Maybe. Can I lift this out? Can that lift up? Okay, so that has a little more clearance than it did, so that's a good sign. Pretty much the only thing that's holding me back here is this grommet. So I think what I need to do is cut the wires, and this is just not the right thing to do it. I seriously doubt these are going to be enough. But I can give it a try. Nope. They are not enough. Let's see. There. Alright, so that, one more wire. And those are, blacks are both commons, it won't matter which one is which, so I don't have to worry about that. Okay. Alright, now Now we're cooking. All right, so now I suppose if I were really going to be gentle about it, I'd desolder those wires, but yeah, I'm not. I'm not going to be gentle. I should be, but I'm not going to be. Oh, hey, that's nifty. That just popped right off. Okay, so that's the ground from the bottom of the switch. And let's see, let's just heat shrink around that wire. I don't know. I suppose I can take most of it, and if it's not going to work, I'll clip it back. So. It's not going to work. There we go. Oops. So that's the line filter capacitor. 1/10 of a microfarad. The casing's looking all cracked. Damage I just did notwithstanding. But it doesn't look blown. This stuff's pretty thoroughly coated. I don't see any bulging capacitors or anything that says it's about to blow. And it really looks in fine shape. And the capacitors could easily be bad, but the back of it doesn't look damaged or in bad shape. I don't see signs of corrosion. No. Click of death. Anyway. And there's a small thing lying in the bottom here. And a few spare parts. Be lucky if I figure out where those went. So anyway, the replacement, this has to be broken off, and it's going to go like so, DC, AC, and this is gray as DC, brown as AC. And hopefully there's this. Yeah, I think it's kind of a shame. Oh well, you know what? Maybe, no, not really. I might have to splice it to make this work. I hate splicing. Oh well. So, break this along here. There we go. That was easy. This goes in the bottom, and we have a bag of goodies here. A couple of butt splices, or whatever they are. I don't know what those are called. Standoff. 1, 2, 3, 4, 5 screws. I'm going to guess Crap, I may not be able to get it in with that grommet in place, huh? I think I can. Yeah, there we go. Yep. Okay, cool. Okay. So. Once the old PCB has been removed, you can now mount the new universal PCB. For this enclosure, be sure to break off mounting points and clearly marked. Mount the new universal PCB to the brass standoffs pre-installed on the universal PCB with the M3 screws enclosed. Mount the new universal PSU. Reuse all mounting screws. Yeah, okay. I just wanted to make sure that was what was expected. So, I believe these were my original screws. So they will just slide in like so. I'll just let them float until I get this figured out. Anyway, there we go. Some pictures of the project as it's gone so far. Mud dauber nests in all their glory. This thing was caked. When I got it originally, this thing was caked with all sorts of mud dauber nests. It had been sitting in a barn. No idea how long. The scrapper that found it said that they'd been cleaning out a farm for about 7 years. There's that much to go through. It was taking him that long. So it had been there for 7 years and probably another 15 or 20 on top of that. Who knows? But when I found it, there was all those big, nasty, ugly mud dauber nests, which the nests look scarier than the wasps are. Mud dauber's just it's a form of a wasp, not a particularly aggressive one. You don't bother them, they don't bother you. But they make these big nests of mud that are really quite impressive if you give them enough years to work on it. When I was working with my dad, we'd work on several farms that he worked on. I got used to, every time I walk into a barn, I got used to looking up, because it was pretty impressive, the critters that lived in the rafters and the nests that they built. You just had a tendency to always look up and kind of, situational awareness, and wanted to know exactly what you were walking into. But despite all the nasty mud dauber nests, it actually turned out that there was no real visible damage on the motherboard. I was actually quite impressed with how little damage there was overall. Now the thing I'm wondering is where the ground goes on this. There's all sorts of markings next to the holes, but I don't see anything that says ground. I mean, I guess it doesn't really matter. Oh, you know what? It was probably here. That's where it would have been. That was that one screw it took out. Now I remember. In fact, I know what I'm going to do with at least one of those nuts, and probably a washer. In fact, I know exactly which one. Is this lock washer goes right there. So there you go. I know what some of my spare parts are for. That's a good sign. Let's see. So this goes on the back of the switch. On the top, this is the ground that goes to the wall. This is blue is my ground that let's see, is going to hook into the power supply, and these are just push down pins. So I have to strip the ends of those darn things. And if I have this hooked on here, oh yeah, I got plenty. I'll make that. Right, line ground, so it's LGN, line ground neutral, so brown will go on this and blue will go there. And then on the other side I've got these gray pieces, these gray wires, and I think, because I didn't take the grommet out, I think I'm going to have to strip these in place and put them on one at a time. And my two commons are middle. Okay, so the back of it is marked for what the actual voltages are, and these are color coded for the voltages. What the color codes are exactly, I don't remember. I could probably figure it out looking at the board, or I could just look it up. So it depends on what mood I'm in. But yeah, there you go. There, it's on the board. Boy, they did a nice job. Every color is marked for exactly what voltage it is, so I know. Anyway, first things first, I've got to strip the ends of each of these wires, and that, let's see, I don't actually have a wire stripper. I got wire cutters, but I don't actually have a wire stripper. I do, however, have an X-Acto knife. So yeah, this is going to take a little while. I'm not exactly sure how much I need to expose. Probably not terribly much. Probably not a whole lot, so maybe slowly. There we go, I can feel it rubbing on wire. Let's see, I got my elbows, I do. Let's see if I can get that twist off. Oh, must not have cut it enough. I'm pretty sure it's not going to twist. Oh, there. And crap, it is braided wire. I guess I should have expected that for DC. So yeah, this is going to take a while. There we go. Now, out of curiosity, oh, wrong power supply. How does that fit for you? Yeah, that seems to work. I'm not really crazy about these sorts of systems. These are just there we go. These are just spring-loaded latches. So I just push that down and that opens up a little spring-loaded metal contact. Push the wire in, let go, and the pressure of it holds it in place. It's not exactly what I would call a permanent connection, but that's what we got. If I'd been smart, I would have ordered a replacement DC cable, which then I could just replace the grommet, push it on the pins, and I'd be done. I wouldn't have to strip these wires. But, well, I guess it wasn't smart. But we'll get it done. So. And where's my cut? There it is. There we go. So that worked. Just gotta keep those splaying because otherwise they get really hard to put in. Alright. 2 down, 4 to go. Yeah. While I'm at it. I wonder if I can just do this. Maybe make this job a little easier. Yeah, I'd say that helped. Oops. No, let's get this out of the way. Better. 3 down. I tore apart the the floppy disks. Those had some living surprises in there for me, which was rather disgusting. That's okay, I survived. They were just pupa. The only thing I haven't opened up yet is the monitor for this. The monitor works. It works quite nicely. There's that one picture that shows my C64 hooked up to it. It works nicely. The brightness control on that is a little bonkers. Brightness or contrast, whatever the knob is, I don't remember. But the pot is no doubt dirty, so I just got to clean that out. Just work it a bunch and see if I can get that to clear up. But otherwise, I think the monitor actually will work pretty well once I get to it. I have to open that up and gosh, just not getting that cut. I have to get that opened up and cleaned out because there's no doubt some muddy surprises for me in there too. That's okay. Finally. Work smarter, not harder. Okay. Number 4, number 5. And last one on the DC side. Kind of lost track of where it was. I'll have to. There we go. There. I think that'll be enough to make contact. So make sure that my wires are bundled nice and tight. And give them a little twist. There we go. Ah, come on. Okay. All right. So I guess I have to hook these up to here. I need to get those hooked in there, which probably let's do let's do this one first. And just in case, I hate these things. Oh, I hate these things. But just in case, I want to give myself a little bit of a pigtail. Make sure I've got enough to actually make that work. I'll set this down here again. If I'm, ooh boy, that's not going to give me much, is it? What was that hooked to originally? Oh, it was hooked to that post, wasn't it? Like that. I see. Yeah, I don't want to do that. I'm just not going to do myself much. I hate to do it that way. Just not give myself much. Think. I think. Oh, wait a second. No, that's fine. Yeah, I think it's okay. So I can probably snip it right about here. It's not much. We'll see. All right. X-Acto knife. So. I like to use my fingers like this, so my X-Acto knife is something nice and soft to cut into if I slip. I think that's important. Hardy har har. I don't know. Now, we'll just stick that in there first. Please. Come on. There we go. Stick that in there like so. That's okay. Just dry fit that. Yeah, I think I'll be okay. Okay, I'll have enough contact on it, I'll be fine. Okay, so that's good. And this, we can just cut. Right here, I think. I will have plenty of reach on that. But yeah, those disk drives cleaned up real nice. And I pulled the belts off on the bottom. And the belts, these skinny little 11-inch belts, fiber reinforced. In really good shape, actually. There's a little bit of deformation while they were pulled for a number of years around the smaller pulley, but they're still pretty flexible, so I don't think even that would be an issue. But all the same, I'm going to replace them. And you can buy new belts made exactly to those specifications from console5.com. They have them made specifically for Apple II disk drives. And I have a duo disk unit, but the disk 2 unit, which is the more common type, they'll work on those too. It's the same thing. And one belt costs you, I think, 11 or 12 bucks, but given the fact that there was never any standardization on belt-driven devices when they were common, the fact that you can replace them at all today is quite remarkable. So they're not out of line to ask that price, I suppose. I'm going to pay it anyway. There. So neutral is cut for the AC side. Now we need to get the DC harness hooked back up. And my color coding is as follows. There's my cutoff. Okay. -5 volt is the blue wire, which is first connection. Stranded wire. Gotta love it. Come on. This is going to be a pain. I could set it down, but I don't think that's really going to be much easier. Let's see if I can just kind of use this. There we go. There's no way I'm going to get it if I put it down in the pan. At least, I don't think I will. There we go. There. And then -12 is green. +12 is yellow. And then I'm guessing +5 must be, yeah, +5 is orange. So -12 is green, +12 is yellow, and +5 is orange, and the blacks are common. The common are the middle two. So they're going, oh, they have 2 +5 connections, which doesn't matter in this case. I only need to use one because they're joined anyway. So the +5 is orange. So that these things got to get pulled back a bit. There we go. Get that twisted. Retwisted. This whole thing is pretty twisted. Okay. +5. Just check it again. Oh, wait a second. +5 is orange, and that's going to go... Oh, I see. That goes on the other side. It's a good thing I checked. So -12 is what I want, actually. And -12 is green. So green is what goes next. Stranded wire. I suppose I was thinking a solder blob would certainly help keep things together, but then I might not get it in there. I almost guarantee you I won't get it in there if I do that. So I think I've got to take my chances. Maybe I had it, maybe I didn't. Didn't feel like I did. Yeah. Not my favorite thing. So, in retrospect, I might recommend buying the DC harness, because stranded wire is crap. I would definitely recommend buying the DC harness. At least strongly considering it, though. I think you have to reuse the... Well, maybe you don't have to reuse the grommet. If you do, I don't know how you get that out of there without busting it. I'm just not brilliant when it comes to stuff like that, I admit. I admit it, I know it. Okay, so +5 and +12 are the last two. +5 is orange, +12 is yellow. We'll do those next. Oops. You can install it in as quick as 15 minutes, the instructions say. And that's what the instructions say. There we go. And yellow is the last one. Okay. And then my commons in the middle. One. And two. Nope, 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 nope. You're not going in like that. Ah, come on. I realize I was out of picture. Oh well. Probably been out of picture for quite a while. There. I think they're hooked up. I guess I could try to check for continuity real quick. Yeah. Let's just check for continuity. I mean, I think I'm gonna get a signal, but you never know. So let's see. Wait a second, I think I saw something. Almost. There we go. I think I'm just not making good contact in the harness. But it looks like I got continuity on common. Yellow. Yellow is the very end. Yep. There might be a coating on the backside of these, on the solder that's preventing this from working, but I got a little bit of a blip for yellow, so I'm going to take it as a good sign. And then orange. Oh, come on. Orange is what? Second one for me, of course. I think I saw some. Yep, there we go. And then blue and green. Let's see. Blue is this one here, and that's the last one on the spring-loaded connector, which is right here. Yeah, I think I'm getting it. There's tone, and then green is right here. Come on, we can do it. I know we can. There we go. Maybe. This might be green here. Here we go. I think. Please. Can you tell them? Come on. I think that's connected. I think I'm having a hard time getting it. Yeah, there we go. I got tone. Okay. So it looks like those are hooked up okay. I'm pretty certain this is fine. So the only thing I need to do is, oh, please put it all together. Oh, goody. Oh, goody. Come on. I've got enough on the blue. I've got enough on the green. I think I even got enough. I think it's just orange, really, that's holding me up here. I wonder if I can slide that through just a little bit. Yeah, there we go. There we go. It slides a little bit. I don't think that's enough for me. Yeah. There we go. Okay, so I think we mount it like so. Did I ever tighten these down? I don't know that I did. Not really. I'll do that right now. Tighten just a hair. And then get that screwed in. Okay, so the the PSU main board is mounted. Let's get this hooked in here. Where it belongs. Need a little extra slack to get that pushed in. There we go. There. Okay. That seems to work. I got plenty of slack on that. Let's pull my other wires out and get this hooked on the bottom where it belongs. That's probably good enough contact for what I gotta do. I don't think I can't push it on any harder anyway. And then this. And then we'll mount our ground to the side of the box. Oh, that's going to be tricky. Okay, hang on. Of course. There. Can I turn this slightly? Get it started. Why do I feel like there should be a very simple solution to this and I just ain't brilliant enough to figure it out? We try that. Okay, let's try this again. Just got to get started on that nut. Fine kind of blind, I can't really tell when it's aligned properly. You stinker. You stinker. I don't have a small enough. Maybe I do. Maybe I do have a socket small enough for that. Hang on. Or big enough. Depends on the perspective there. Is that gonna work? I'll be darned, that will. Let's try that. It's just gonna sink in too far. Feels like I almost got it and it's binding on the threads. Oh, come on. Almost got it. I almost got it. Come on. Boy, I am not getting that. Okay. First off, let's just make sure that that actually fits on it. Well, what gives? Does that fit on it? Maybe that was too small. Maybe I was using the wrong size nut. Yeah, I'm the wrong size nut. Alright, here we go. Let's try this again. And again. Come on. There we go. Take? Yeah, there we go. Haha, got it. Okay, cool. So let's get that tightened down, at least somewhat. I don't know that I can, how tight I can get it here without a, maybe. Yeah, so you're only going to get it so tight anyway. Well, that's certainly good enough contact. I don't think I need to worry too much about it. So let's see. I guess it's time to see if this thing blows up. Okay. Where's my power cord? There's a power cord. Looks like that'll carry electricity. Right there. And actually, tell you what. Yeah. There we go. Let's just plug that in there, and let's zoom this out just a hair. There, that's better. And now, moment of truth. Set my voltage. Because I got plus and minus 12 and plus and minus 5. Here's my harness. And see what happens. No explosions. It's always a good sign. And let's see if we got contact. So here's my neutral. And minus 5 volts on blue. Correct. Positive 12 volts on yellow. Correct. Minus 12 volts on green, correct? And positive 5 volts on orange. There you have it. A functioning power supply. Oh, brother. So now that we got that out of the way, I think I'm going to take a little break. Oh, what time is it? Gosh, I'm going to call it quits. So we'll start this up another night and we'll see if we can get the motherboard put back together and power this thing up. See you later.